Hi, welcome to the fourth interrogation video. Let's just get started. Kirchhoff's junction law applies at the junctions. The input current I splits into currents I1 and I2 at the left junction. On the right, the two currents are combined into current I. According to the junction law, I equals I1 plus I2. So we know that this Kirchhoff's current junction law is saying that when you have when you have a junction, the current on the left side equals the current on the right side. Wait. And I1 plus I2, the two branches when combined, they're the same. So they follow this pattern. We can apply Ohm's law to each resistor along with delta V1 equals delta V2 equals delta VCD to find that the current is. So let's look at this figure 28.21 first. So we know that the voltage, the potential difference, is the same in different branches in a parallel circuit. So we know that delta V1. So it's like right here equals delta V2 equals delta VCD. So they're all equal. So when you apply this Kirchhoff's junction law, I equals I1 plus I2, and you plug in Ohm's law, you get this equation right here. And since V1 is delta V1 equal to delta V2, you can substitute them with delta VCD according to this equation right here. So once you plug it in, we can take out delta VCD and then combine the other two. I forgot what the math rule's called, but yeah, so you get like this equation right here. Suppose, as in figure 20.21b, we replace the two resistors with a single resistor having current I and potential difference delta VCD. So it's saying that this circuit and this circuit have the same potential difference between point C and D. This resistor is equivalent to the original two because the battery has to establish the same potential difference and provide the same current in either case. And that makes sense. A second application of Ohm's law shows that the resistance between point C and D is it's this equation. So based on the last equation right there, we know that I equals delta VCD equals 1 R1 plus 1 over R2. And then when you multiply that, divide that over, it's I over delta VCD equals 1 over, like that. And then when you flip both sides, it becomes delta VCD over I, and it's to the negative 1 power. And we know that voltage over current equals resistance according to Ohm's law. So that equation makes sense. The single resistor RCD draws the same current as resistors R1 and R2. Yes, because they all go through the same point C and D. So the current inside has to be, it's the same current. So as far as the battery is concerned, resistor RCD is equivalent to the two resistors in parallel. So this one bigger resistor does the same job as R1 plus R2, or like not R1 plus R2, but the two smaller resistors combined. There's nothing special about having chosen two resistors to be in parallel. If we have n resistors in parallel, the equivalent resistance is this. So that's 20.24 is pretty much like this equation right here. So it's saying that no matter how many parallel resistors we have, we can always replace them with one resistor of the same resistance. The behavior of the circuit will be unchanged if the n parallel resistors are replaced by the single resistor R equivalent. Yeah, that's what I just said. The key idea of this analysis is that resistors in parallel all have the same potential difference. Yep, that makes sense. So let's try a practice problem. Two of the three resistors in this figure on the left are unknown but equal. The total resistance between points A and B is 75 ohm. What is the value of R? So we know that these two have the same resistance, and the potential difference between AB is 75 ohm. So let's use this parallel resistor equation. So let's plug it in first. So let's call this 1, 2, 3, R1, R2, R3. So R equivalent, pretty much our total, same thing, equals 1 over R plus 1 over 200 ohm plus 1 over R. So when you can combine these, simplify this into 1 over 200 plus 2 over R. And now in order to solve this, we need to... Oh, by the way, R equivalent, meaning, like I said, it's the total resistance between point A and B, and it's given the problem is 75 ohm. And then we need to flip both sides to get rid of the negative exponent. So it's 1 over 75 equals 1 over 200 plus 2 over R. And you move that over. And manipulate that a little bit. It's 2. Wait. Well, let me just use my calculator to get this value right here. So 0.008333. So R equals R equals 240 ohm. So resistance 1 equals resistance, resistor 1 equals resistor 3 equals 240 ohm. And that's it. Thanks for watching.